prompted me. Okay, so when you resolve this component of the weight is equal to mg cos theta, the component perpendicular to the plane, the component of the weight perpendicular to the plane is mg cos theta. The component parallel to the plane, which is this part, would obviously be mg sine theta. So this is perpendicular. Now, because of equal vectors, we can bring this parallel vector along the plane to be equal to, we can equally bring this component along the plane. So we have mg sine theta. Meaning that on an inclined plane, there is always a naturally existing mg sine theta resultant force acting down the plane. You see, its direction is down to the downside of the plane. So there is always a resultant force of, mg sine theta acting down the plane. So that is why when you have an inclined plane, bodies or objects placed on an inclined plane is always rolling down. Because there is always a resultant mg sine theta acting down the plane. Please, are we okay? Are we okay? Inshira?
Yes, please.
Irene, Adita, Janisha, and Co. Are you okay?
Yes, please.
Okay. Then, this is the scenario. Okay. And we are told that the body moves at a constant velocity down the plane. And the beta part says we have to find the force pulling the boat in newtons. Okay. So, we look at equilibrium of forces on the plane. Total forces acting down must be balanced by the total forces acting upwardly. Okay, so the sum of forces acting down the plane, we have the force pulling it F plus the everyday existing mg sine theta. And this must be balanced by frictional force. Okay, please, the first question asks that we find the normal reaction. Okay, so let's find the normal reaction first. The normal reaction R is balanced by mg cos theta. Therefore, R will be equal to the mass of the body, 200, times acceleration due to gravity, 10, by cosine of the angle of inclination, 15 degrees. So put them together and then give me the final answer. I need the answer in 1 decimal place.
This is 1,931.9.
1,931.
Yes, please.
Come again, 1,000.
931.
Okay. So 931.9. Okay, Newton. So that's the normal reaction. Okay. Then the beta part says that the force pulling the boat, we are to calculate for the force pulling the boat. And that is what I was earlier doing. So we are saying let the force pulling the boat be F. So F plus mg sine theta must be balanced by the frictional force acting against it. Therefore, F will be equal to friction minus mg sine theta. Okay. Now, what is frictional force? Frictional force F is equal to the coefficient of static friction times the normal reaction R. Okay. So, what is the coefficient of static friction? The its value is 0.8. So 0.8 times the normal reaction has been calculated, which is 1931.9. So we can quickly calculate for the frictional force. Please do so for me. 0.8.
1,545.
1,545.52. I come again.
545.52.
1,052 Newton. Good. So if there is a frictional force, then the force pulling the boat F would be equal to 1,545.52 minus, calculate mg sine theta for me. What will be the value of mg sine theta? So 200 times 10 times sine of 15.
517.
517.6. Okay, so subtract that from the frictional force. That will be 900 and what? Nine hundred and. Oh, I'm waiting for you. Hey, are you there?
1,027.92.
So approximately 1,028 Newton. So this will be the force pulling the boat to the sea. Please, any question? Any question? If you are not clear with something, bring it up so I can explain, then we move on. Okay. All right. So please, if you are writing, quickly do so we can continue. I'm giving you 2 minutes to rush through in writing it. Do I clean the board?
Yes, please.
Okay. Now, the last question is that a broken down vehicle is being pushed by 3 men. A broken down vehicle is being pushed by 3 men with respective force. So F1, the first force has a magnitude of 22 Newton at an angle of 30 degrees. Then F2 is 350 Newton at an angle of 90 degrees. Then F3, 240 at an angle of 120 degrees. Calculate the magnitude and direction of the resultant. Okay, so 3 men are pushing the vehicle with different forces at different angles. Practically, it doesn't work like that, because when you are pushing a car, you combine forces. So you all push it in one direction so you can overcome the weight. But when you are exerting the force at different angles, it cannot move the load. Okay, so practically it doesn't work, but it's a question. So we have no qualms. We have to just solve it. So how do we determine the resultant force? And what is a resultant force? A resultant force is a single force whose magnitude is equal to the combined summation of the combined forces. So what single force, when put together, what single force would have a magnitude which is equal to the effect of all these three? That is the resultant. And that's what the question asks that we find. Okay. Gloria, have you fixed your audio problem? Gloria? I guess no. Okay. So, how do we determine the resultant? Here, we'll use resolution of forces into components. We'll pick each and every force, resolve it into its vertical and horizontal components. Okay, so editor, can you try F1 for me? Resolve F1 into 8 vertical and horizontal components for me. Can you do that?
No, please.
Okay, then Inshira, yours is F1. Then Trifina, are you there?
Yes, please.
Okay, this is Inshira stroke Irene. Then F3, Trifina and Regina. Edith, I will explain, so you relax, okay? Then F2, the silent Gloria. And Janisha. So resolve, you are resolving F1, F2, F3. Okay, and that is your assignment within 3 minutes time. Whilst myself, Janisha, and who else? Edita, myself, Edita, and will be spectators. The rest of us, did I give Regina? Yes. The rest of us will be waiting for their feedback. Start when? 3 minutes. You are doing this within 3 minutes, and I'll come back to pick your final answer. Okay.
Yes, please.
It's 1 o'clock exactly. 1-3. I'm taking my answer. So please, if you haven't been assigned anything, you are a jack of all trades. You are answering everything apart from myself and Edita. So a minute more. A minute more. All right, time is up. So let's see what Inshira and Irene had for us. But I was thinking you discuss on the platform. You are all silent as Gloria. So, Inshira and Irene, what did you get from the X and Y component of F1? Inshira? Inshira?
And so I got F sin 30.
But no, F has a value. The magnitude of the force is 22. So
22 sine 30 as
as
11.
So which one is the X component and Y component?
I think it's the X.
The X is 22.
Sine 30.
22 sine 30. Okay, I will explain for the benefit of those who are not clear. So we'll eventually go through it and mark. And what is the Y component?
22 cos 30.
22 cos 30. And you are saying the X is equal to
11.
11 Newton and the Y
19.1.
19.1 Newton. We shall see. That's what she says. Okay, Gloria and Janisha. Janisha, Gloria is a silent killer, so you would have to take it up. Janisha.
Okay. The forces lying vertically or horizontally cannot be resolved. So X is 315 Newton. 315, no.
1 Newton
And
Newton.
in the second plane.
And Y is
90.
oh no, you have given me the X component. What about the Y component? That is 0.
Divided it. Yes.
So we shall see whether you are right or wrong. Okay. So F3, so X3 and Y3. Regina and Trifina, what did you also make?
Please, I got for the X component 240 sine 120.
240 sine 120.
And
And
240 cos 120.
120 degrees. So this is equal to
So 207.8 newtons.
207.
0.8.
207.8 Newton for the X, and then the Y.
I got negative 120.
All right. So for the benefit of those of us who perhaps are not so clear, let's see. One of us is gone. Let me see who is not here. I can't even see. Okay, so let's continue. Now, this is how I also do it. So if you are right, you'll be marked. If you got it wrong, you'll be marked wrong. So F1, 22 by 30 degrees. If I'm resolving this into vertical and horizontal components, I draw my cardinal points. Bearings. With bearings, angular measurement is always measured from the north. Trigonometry, it is anti-clockwise from the x-axis, but with bearing, angular measurement is always taken from the north. Okay, and force is a vector quantity, so it squarely falls under that. Please, are you okay?
Yes,
So,
please.
To measure 22 at an angle or bearing of 30 degrees, I measure 30 degrees from here. I'm assuming what I have here is 30 degrees. So this is 22 Newton. This is the angle, 30 degrees. This is the magnitude from the starting to the ending point is the magnitude of the force. Okay. Now, if this angle is 30, Danisha, what will be this angle? If this is 30, what will be this angle? Anybody else? If this is 30, what will be that angle?
60 degrees.
So 60. So you can resolve this force into horizontal and vertical component using any of the angle. It can be 30, it can be 60. The value must be the same. Please, are you okay? So if I
Yes,
use
please.
this, if I'm using 60, the vertical will be this. The vertical is always perpendicular to the horizontal. So this component must be F vertical, which is Y. F horizontal, which is X. Therefore, from here, Fx would have to be, when I use 60 degree, this would have to be 22 cos 60. And this must also be equal to, when I use 30 degrees, this side becomes, which is the opposite to the angle, becomes the X, Fx. Though this side is opposite to this angle 30 degrees, but because it falls within the x-axis, it becomes Fx. This side, which is the adjacent to the angle, because it falls within the y-axis, becomes Fy. Please, are you okay? Are you fine?
Yes, please.
Meaning that if I use 30, this must still be 22 sine 30. And they should give me the same angle. Cos 30 is half. So 22 times half is 11. Sine 30 is also half. 22 times half is also 11. So whichever way we look at it, the value is the same. So Fx is equal to 11 Newton. Then Fy, if I use this side, if I use the angle 60 degrees, would be 22 sine 60. If I use 30 degrees, it is 22 cos 30. Janice, are you Edith, are you fine? Patience.
Yes.
Yes, please.
Okay. Now what is sine 60? Sine 60 is root 3 on 2, aka 0.8660. So 11 root 3. Cos 30 is also root 3 on 2. The same 11 root 3. Okay. Of course, let's change 11 root 3 to decimal. 11 times root 3. Ishra, quick. 11 times root 3.
19.1.
Good. So 19.1 Newton. So looking at what we have, I think Inshira and Irene got it right. You will not clap for yourselves. Inshira and Irene. You won't clap for yourself. Okay, then let's look at Gloria and Janisha. Let's judge them. Theirs is 315. Can I clean it? Because we are using, I want to maintain this, and then we use this side for our.
Please, I have a question.
Ask your question.
Please, I don't understand how the vertical components for the 60 is cos 60.
Oh, the vertical
Because
is, oh, you see, I said you can use this, the angle 60 degrees or 30 degrees. If you use 60 degrees, okay, sine 60 is equal to opposite, which is Fy over the hypotenuse, 22, correct?
okay.
So Fy is 22 sine 60, and that is what we got here. Okay.
Okay.
Now, if we also use, I said we can also use 30 degrees. Either you use 30 or 60. If you use this angle 30 degrees, okay, this side is the adjacent to the angle, isn't it?
Yes,
Is the
please.
adjacent to the angle 30 degrees, even though, and it falls within the y-axis. So if I'm looking for this side, I'll use cos 30 degrees is equal to the adjacent, which I'm looking for, Fy over the hypotenuse, which is 22. Fy is equal to 22 cos 30, isn't it?
Yes, please.
So this side becomes Fy because it falls within the y-axis. Because it falls within the y-axis. That's why we are calling it as Fy. Is that okay?
Yes, please.
So it is either you use this side or this side. The value is the same.
Okay.
And coincidentally, we got the same answers for both sides. Okay. So let's, Gloria and Janisha, a judgment time for them. 315 at 90. So if I'm taking my measurement, angular measurement from the north, I have 315. And the angle is 90. Okay. Now, if you are going by x,